Hello and welcome back, folks. Lesson 6-8, Chapter 6, Lesson 8. Fractions with different algebraic denominators is where we are heading. More study of fractions. And to remind you where we've been doing algebraic fractions with like denominators, unlike denominators. For instance, that was probably the last year or two, 8/7 minus 3/10. Then we stuck in some variables, but still needed to get common denominators. Now we are going to have denominators with variables inside of them. But we will use the same process to get the same size slice, to get that common denominator. And of course, things get a little more challenging in algebra class, but you are well on your way of understanding how to take care of that business. Now, if you need, pause, take a look at your assignment. This is assignment 20. Pause, come back when you're ready. And here's assignment number 21. Pause and come back when you're ready. So I want to take you back a few years and just talk about how these are really a similar style of problem. We've already mentioned that you cannot take away fifths when you have thirds. But if you cut them up into the same size slice, you quickly realize that both of these can be turned into 15ths. Naturally, don't say 1/3 is the same as 1/15, say 1/3 is the same as 3/15, and don't say that 2/5 is the same as 2/15. 2/5 is the same as 3/15. And yes, as we've been learning in 7th grade pre-algebra class, it is possible to go up and then go down and to end up with, well, end up underwater, end up a small fraction. This could, of course, reduce. But I just wanted to really focus you on the process of getting common denominators. 3 times 5 gave us a total of 15 slices, right? So let's take that same process and examine it when we have algebraic denominators. Let's say we still have one part cut up into thirds, but the other part is cut up into B sections. Now, I can split this up into thirds with the red, but I don't really know how many B is. I don't know, should I put a dot, dot, dot? I'm not sure. Maybe I'll put a dash line just to show that it does keep on going, but we don't know how many times. However, we can now see that you will have B columns of 3. Therefore, our least common denominator will be 3B. All right, but naturally, what we cannot say is that A over 3 is the same as A over 3B. After all, this had to get cut up B times to get to 3B. So let's be fair to the numerator. And therefore, our new numerator is AB. Now again, to be very clear, AB over 3B is the same as A over 3. Those are equivalent fractions. I guess you could say they're just different size slices. Now let's take a look at the second fraction. The second fraction, we have B, we need 3B, and therefore, what might seem obvious is we'll multiply by 3. Therefore, 2 times 3 is 6. B times 3 is 3B. So once again, 6 over 3B, that's the same amount of pizza as 2 over B. That's a mystery. We don't know how much that is. We don't know what B is. But at least now we have that common denominator. So whatever those slices are, we're going to subtract a B slice of that minus 6. So our final answer will be AB minus 6 over 3B. Now, As always, you can check to see if anything reduces, but it has to reduce into every single term. For instance, b goes into this term, it goes into this term, but it doesn't go into 6. Therefore, you cannot divide by b. In fact, no number or variable will divide into every part. So I just wanted to tie these two examples together. When there were numbers, it's a little easier to show how to get those common denominators, how to get the same size slice. It's a little tougher with variables. If you need, pause, rewind, listen to it again. Meanwhile, we're going to go on to 3 more examples. First example, we have 5 over r plus 2 over r squared. Again, we don't exactly know what r is, but we do know that anytime we have to add fractions, we've got to have common denominators. And to get a kickback to least common denominator, what we found is if you circle everything that's in common and write it one and only one time, and then you multiply it by every other part, quickly you would see, and some of you now have the mental skill to see, that r squared will be our common denominator. What I like about this is that the second fraction does not need to change, but the first one does. You cannot tell me that 5 over r is going to be the same as 5 over r squared. No, I don't think so. So what would we have to multiply both numerator and denominator by to get to r squared? Oh, well, come on, Mr. Callan. R times another r would get you to r squared. So let's multiply both numerator and denominator by r. And I'm going to stop saying this, but if I can just point out, please, that 5r over r squared is equivalent to 5 over r. All right, but the good news is now we have common denominators, so we can add 5r pieces plus 2 pieces and write that as whatever over whatever number of pieces that is. Nothing will reduce into both, and we have our simplified fraction. Let's keep going. Maybe a couple more examples will kind of help you with your understanding things. We're looking at x, we're looking at y. What could we get for a common denominator here? Naturally, that would be xy. So let's look at the first fraction. What would we have to multiply here to get that common denominator? Well, x times y would give us xy. So let's be fair to the numerator. Anything you do to the denominator, you must do to the numerator, which means now we have an equivalent fraction, 7y over xy. Now let's do the same thing for the second fraction. What could we multiply here to get xy? Mr. Callan, that would be x. So let's be fair to the numerator. And we could say that 5 over y is equivalent to 5x over xy. I'll talk more about this in class, but just to note, anytime we do have algebraic variables, if you have those together in a term, you should write it alphabetically. Now that we have our common denominators, we can go ahead and subtract 7y minus 5x. Are those like terms? Can we combine those? No, they're not. So that is as pretty as it gets. Final answer will be 7y minus 5x over xy because we found that common denominator. All right, let's wrap up with one more example. Now I'm looking at 2x and I'm looking at 3x, and I see they both share an x, but what would be the least common multiple of 2 and 3? And some of you see that pretty quickly. So we now have a common denominator of 6x, but that's going to change everything, isn't it? Because in order to get from 2x to 6x, we would have to multiply by 3. 3 times 2x is 6x. Be fair to the numerator, and we get 9. What would we have to multiply the denominator by? To get 6x, we'd have to multiply by 2. 2 times 3x is 6x. Be fair to the numerator, we get 2y. So now that we have the same size slice, we can go ahead and subtract those pieces. 9 pieces minus 2 times y pieces, whatever that means. And I almost thought we could reduce because 3 goes into both 6 and 9, but 3 does not go into 2. 2 goes into both 2y and 6x, but does not go into 3. So as a matter of fact, this is our final answer in simplest form. Feel free to pause if you wish, rewatch, go on back. I'll go over these examples again in class. For anybody looking to get ahead, you're welcome to start this up. Assignment number 22, page 171, number 7 to 45 odds, 46 to 49 all. Let's grow.